Lesson 13.2 is Riemann and trapezoidal sums from tables. So it's definitely easiest when you have a graph in front of you because then you can visually see the rectangles you're making and then get the area for them. It's a little harder when you have a table, but I went ahead and included a graph of the table just so that we can have that connection, but we've got to be able to do it without it as well. It says selected values of f of x are shown in the table below. What is the right Riemann sum approximation for the integral or the antiderivative of f of x from 0 to 5 using 4 subintervals? And so notice it doesn't say equal subintervals, so that doesn't mean your rectangles are always going to be the same width. But the points here are at 0, 17, 2, 13, so you can see this rectangle is going to be 2 wide, 3, 10, 4, 6, so that's 1, 1, and 1. So the rest of them are going to be 1 in width. But being a right Riemann sum tells us specifically about the heights of each rectangle. So if I were to draw this first one, it would touch the right point, which would be here. So that rectangle has a height of the 13, not a height of the 17. So we actually don't use the leftmost y value at all. The next one would have a height of the right-hand point between the two, and that would be at the 10. So we'll have this be one subinterval, this be another subinterval, 3 to 4 be another subinterval, and it'll be the height at 4, which is 6. And then the last subinterval would be between 4 and 5, and it'll have the right-hand height, which is the 5. Okay, so without the visual, what I would do is first think, okay, right-hand sum, here's one subinterval, here's 2, here's 3, here's 4. I'm not going to use the left-hand one. And so then I would have my width be a difference of 0 to 2, so that's a width of 2. Then my height would be f of 2, which is, 13, not 3. So my height is 13, plus the next width, since it's 2 to 3, is a width of 1. And then the height would be f of, of 3, which is 10. And then the next one, 3 to 4, that's a difference of 1. And then that height would be f of 4, which is 6. Plus the next difference is 1, and then f of 5 is 5. So that tells me that this area should be 26. This one should be a 1 by 10, so that's 10. A 1 by 6 would be 6. And then a 1 by 5 would be 5. Add that all up, we get 36 plus 11, which would be 47. Okay, so that's a right-hand sum. Let's do number 2. Now we're doing a left-hand sum. We're going between 0 to 14 and having 5 subintervals. So 0 to 2 will be 1, 2, 3, 4, 5 rectangles. This time being left-hand, my first box would hit this y-intercept here and make a rectangle like that. So I'm going from the leftmost point, I'm going to be above and have some extra here and here. But this one now I'm going to be below. This one I would be below. Oh, sorry. Whoop. I missed. Okay, so that one would be there. So again, if we were going to do this without having a visual, I would think left hand, I'm going to want to use all of these. So for this interval, I'm using the 19. For this interval, I'm using the 9. I wouldn't actually use the 25 at all. Ooh, that was a weird sound. Okay, and then I want to find the change in my x's. That's my widths. So this width would be 2, 3, 4. Sorry, I lost my track. 2 and 3. And so then I'm going to have a width of 2 times 19 plus a width of 3 times 9 plus a width of 4 times 5 plus a width of 2 times 12 plus a width of 3 times 18. And that should get an area of 163. All right, number 3. Now we're doing a midpoint, which is personally my favorite. We want 4 subintervals from 2 to 14. And so this first one, we want the middle of the 2 points. So our height would be here, which is pretty accurate for that area. And then the next one would be this midpoint. So it's going to go a little over and a little under here to here. The next one would be this midpoint. So that one's going to be a little off. And then this one. Okay, so we're going to be using not these at all, the 6 or the 7. We're actually going to be using the height in between. Okay, so we're going to have our first x values be from 2 to 5. So this width would be 3. So 2 minus 5, which is 3. And then the height of the rectangle is going to be 6.5 plus. Then we're going to have the next rectangle be from 5 to 8, which is another width of 3. And then the height's going to be 7.5 plus 8 to 11. So it looks like all of these rectangles will have a common width. So 3 times a height of 9, and then another width of 3 times a height of 16. Which should give you a total area of 117 units squared. There's one more, problem 4, on the next page. And it gets a little more complicated since it's the trapezoid. But if you look on the graph, so that we see what we've got, here is our first trapezoid. This would be our height. And then we've got the 2 different bases that need to get averaged. So remember that area of a trapezoid is 1/2 times sum of the bases times height. Another way you could think about it is you're literally just averaging the bases. So it's base 1 plus base 2 getting divided by 2. That times the height of it. Okay? And so our bases, then we're going to use all of these x values. So this first trapezoid, we're going to have to figure out the height, which is 0 to 4. So that's a height of 4. And I'm going to put it in front instead of at the end. Times, then we're going to average the bases. The bases are going to be the 2 y values because this is 14 and this is 18. So we'll have 14 plus 18 getting divided by 2. And so that'll give me the area of the first one. Okay, the next one's going from 4 to 6. And so that is a height of 2 times, we're going to have the 2 bases be 18 and 20, getting averaged or divided by 2, plus the next trapezoid gets even skinnier. It's got a height of only 1 times 20 plus 21 getting averaged, plus, and then we've got a bigger one. It's actually got a height of 4, and then averaging the 2 bases would be 21 plus 41, all getting divided by 2. Since this is an average, since this is an average, I can do some of this in my head. What number would be right between 14 and 18? Would be 16. So this should be 4 times 16. What number is right between 18 and 20? That would be 19. What's right between 20 and 21? Would be 20.5. And then times 1 isn't going to change it. And then 21 to 41, I don't know. But what you're doing is just averaging, which means literally finding what's right in between. Oh, duh. There's a difference of 20. So split that in 2, that'd be a difference of 10. That'd be 31. But if you need to add them together, of course, do so. I was just trying to find a way to speed up, but see how that got 16. So I got a total area of 246.5.